So in the previous videos, we really just focused on this hexagon cell style that we've tiled over our surface, and really just been focusing on also manipulating the geometry of the cell itself. So extruding that shape either up or down in some areas, creating all sorts of different types of extrusions, whether it was kind of pointed or linear or even kind of rounded. So we're going to take this video in two different directions. First, I'll just show you how you can apply a different type of grid without having to pretty much start from scratch. And I'm also going to take it a little bit of a different direction as well, where instead of actually extruding this surface that's generated by these cells, we're actually going to manipulate the edges of our cells themselves. So actually move them instead of the surface, as you'll see. So, like I said, the first thing we want to do is change our grid or cell type. So again, I'll use the Lunchbox plugin, go to panels, and let's use diamonds this time. Again, it's asking for the same surface, and I'm going to use the same U and V count. Let's get rid of this so we can see it a little bit better. Right, so here's our actual diamonds. So let's, again, kind of change those. I'll stick with that 60-20 value. That way we have still kind of some detail that's going to be retained of those landforms. Obviously, again, if you increase those, the more detail there will be of the original. But notice that this one kind of creates the curves and center points. This one actually creates surfaces for both the diamonds and the triangles. You can see that there's the diamonds in the middle, and then triangles make up the edge to retain that original surface type. So in order to kind of make this a little bit easier, we want to actually join those together and find the center point, because you can see again there's no center point there. So I'm going to go to Set, Tree, Merge. This allows me to combine both of those. So now when I'm editing my cells, since it's two different types of geometry, it's just going to be coming out of one output instead of these two outputs. And then I'm also going to do the same thing to find the center point. So here's the center point for all of this. And again, so I'm not actually manipulating the surface, since that can require a little bit more computing power. I'm actually just going to go ahead and convert those also to curves. So I'm actually just editing the curves. And now you can see with just a couple extra components, we're mimicking the same output that comes from here. So this is where we need to start replacing things. So let's just kind of give ourselves a little bit more room here. So I'm deleting this, and I'm replacing everything that's coming out of this, so these different chords, into those areas. So it's not too bad. It looks like we just have 3 different things that are coming out of here. You might have more depending on how much you produce at the end. So basically remember that this is the geometry of the cell. This is the center point. So here's our geometry. Here's our center point. Another thing I like to do whenever I'm making some drastic changes is that I actually like to disable the solver or lock it. So you can see if I click here, now I got this kind of red border that shows that nothing's going to be computed. So again, I can see that there's cells going over there, so I just kind of drag this and follow it to whatever I'm changing. Okay, so now I see nothing's coming out of there. I've still got these 2 center points, so that's from here, it's going into there, and then that is going over to here. Okay, and don't be alarmed when you see these orange wires now. That's just because, again, it's disabled the solver, so even though there's technically information coming out of it, it's not actually calculating that data. So that's just kind of a visual for why that's happening. So I'll just kind of put these back to where they are, and then I can enable it again. now I've got everything kind of doing from there. And there's actually quite a lot of this I'm going to change anyways, but not at the moment. So let's actually keep this one on. So like I said, I'm actually going to, instead of manipulating the diamond or triangle, I'm actually going to mess around with their edges. So in order to do that, I need to do a couple things. So these are closed geometry, so I actually want to start to fragment them into all their different segments. So the diamond's going to have 4 segments, the triangles are going to have 3. So I'll go to Curve, Utility, Explode. So this basically takes any type of curve and fragments it into those different segments. And you can see that in this panel here, I can see that there's some that have 4, and then at the very bottom it says 3, so that's just showing you how that data is getting divided into those different branches. So what I want to do, I actually don't want to have them all branched out. I'm going to go ahead and flatten this. So now I've got 2,400, almost 2,500 line segments. Okay. So from here, I'm going to, instead of like before where I was analyzing the surface of these points, I'm actually going to analyze the starting and end points of this. So I'm going to go to endpoints, because this is going to allow me to start to change different heights based off of, again, the slope of this surface. So I'll turn this off, and I'll turn this off as well. This is where it's just going to require a lot of repetition. So I'm actually going to go ahead and just delete this. I'll even delete my graph mapper for now. So just like with this component where we were originally analyzing the center point, so we actually are still going to do that. I'm just going to shift this down. So everything, again, which is coming out of our kind of slope analysis. I'm going to go ahead and Control-C, Control-V to copy and paste and bring it up here. So I can see that not only do I have the center points that are getting analyzed down there, now I have points for the start and the end of these curves, and I actually want to analyze those as well, but I do want to do them separately. So again, this is asking for that point. I'm just going to start off with the start point for this one. And that's really all you have to replace. The surface is all still the same coming out of there. Let's just kind of give ourselves, again, a little more room. Because the geometry that we're changing, yep, it's still the same. That's getting scaled. I just kind of want to keep it in that same vicinity of that. Because we are going to use, we want to use the same graph mapper for all of these so it's nice and cohesive. So the same thing, I want to basically use a graph mapper to start moving things. So again, I'm moving these start points, so I'm going to do move. And you're going to see that obviously I'm focusing just on the start points. I'm also going to do the same thing for the end points, but I might as well kind of just work this all the way through so I can copy that group of components and just replace it with these endpoints. So now you'll see that, again, I want to move them within their respective direction. A lot of this, again, is based off of the previous videos, so if you are lost at all, I suggest you go to the first kind of tiling, surface extrusion and tiling videos. So again, I want to create a graph mapper, so primitive, input, graph mapper. Again, if it's pretty flat, let's just hide this for now. I don't want them to move as much versus when they start to get more on these sloped areas, I want it to move a little bit more. So again, I'm going to stick with my preferred Bezier one. Then I'm going to create something looking a little bit like this. And we'll see once we start to move these what that looks like. So again, I want to move them based off of the angle of those areas, but I want it to move based off of this distance. So I'm going to go to vector, vector, amplitude. So again, I'm using this direction to tell me where in this 3D world where I want it to go, and then this is going to tell me how far in each of those directions. So now I'll turn this on just to show you can see how areas that again are flat don't seem like they really move from those original cells, versus as soon as I start to veer off in these hilly areas, there's a little bit more extrusion going on. And again, I might want to adjust this, so I'm going to actually go to math, multiplier, and I'm going to actually, because again, I want this to be kind of subtle looking. I'm going to actually give it a 0.5 slider so it's a little bit more subtle. I can obviously, again, always adjust these, right? So this will, again, kind of show me how much this is, but I'm going to keep it around there. So like I said, a lot of this is pretty much going to be the same, but I'm just going to replace it with this endpoint. And you can see I'm only dragging that start into 2 components, so it's really not going to require that much replacement. And I'll make sure to take my time so you all can see what's happening. So again, I have this. Actually, again, let's just take our time with this. So something I like to do too when I have kind of a grouping of things, so everything that's kind of unique to its group, I hit Control G to just kind of put it in its own special area. That way I can, again, select this, Control C, Control V to copy it. That way I can see kind of just a clear delineation of each one of these to help out. So again, instead of using the start point, I want to use the end point. If you want, you can disable the solver. I don't think it'll create too much of an issue, but again, everything that the start is going to down here, I want to replace with the end. So there's that part. And then there's also this part. So again, there's I moved the start point. I analyzed it first with the surface closest point here, and then I moved that same point. So that's why I have these 2 areas. So again, I'm going to, so I got start there, and then endpoint. Yep. I can always kind of move this down so it's a little more centered, so it looks a little more symmetrical, right? So these end start points are going to this upward direction, these end points are going to this lower direction. Now I can enable it, and you'll see that, again, they should pretty much be in identical locations because they're all being analyzed the same way. So from here, I want to actually go to curve and create a curve from a start and end point. So I've got my start point that I've moved. I've got my end point that I've moved. So this is basically just kind of, again, I talk about it a lot where in Grasshopper, you deconstruct and you reconstruct things. You can see since I've kept this original curve on, we can see just how it starts to differ from the original, right? So again, it's just subtle movements of these diamonds. I don't want it to be too dramatic. If I do, though, I could always change the sliders. In this case, I do want to use one for both of these, so it's just one less step I have to take. So I'm going to replace this multiplier for it, so that way it'll do it for both, because if they're all separate, then they won't begin to match as much. So let's just kind of maybe jump it up a little bit more so we can kind of just see what that effect is. So I can go ahead and delete these now. So the next thing I want to do is, again, try to create, so these aren't just purely extruding up, I want to actually create some thickness to these things. So this is where I can, again, use my scale component. So again, I'm going to use my graph mapper. I want to use the same exact shape, but I do want to change one thing, because again, there's movement and then there's scale. If I want things to stay the same, so if they have a 0 value, I want them to keep a 1 scale, so that's 100% or doesn't change, versus the ones that start to have a slope start to get smaller. So in order to do that, I do want to just double click inside of here. And again, I don't have to mess with the X values, but I do want to invert the Y values. So instead of them being 0 and 1, I want it to be 1. And I don't even want it to be 0, because if it's scaled to 0, then it's going to be disappeared. So I'm actually going to do something like let's try 0.35 or close to a third and hit OK. So the really steep ones are going to be a third of their size. And you'll see, if I hit preview, that it does just that, right? Okay. And again, if you don't remember from the previous videos, what I'm scaling are my cells. So that, or in other words, the curves that have come out of that. I'm using the center point, which is the same, even though it's the center point of the surface. I'm using that as my center point, and then the F is the scale factor. So you can kind of start to see how many are being affected. I kind of want there to be a little bit more. It just seems like there's a couple, so if I want to do that, I can just start to kind of drag this over to start to see more of these that get affected. I can maybe have it more look like this. So now I have a little bit more fluctuation. The thing I have to be mindful, though, is again to kind of keep this, for the most part, pretty linear, or at least consistent and cohesive, is that whatever I do with this graph mapper, I want to do for the other, so it has the same shape. So again, I'm going to Control-C, Control-V. Unfortunately, again, these have different Y values, so I'm going to double click in here and again do 0 and 1. Hit OK. Now I'll just replace it this way and get rid of this one. Now I'll just copy and paste this one. And again, get rid of it. Replace it with that. So it's all, again, the same cohesive graph mapper. So the last thing I want to do now is let's turn off the original, because it's going to start to get a little bit messy. So these are all segments. So they aren't, even though they appear like they're just solid or closed diamonds and triangles, they're still just segments. So in order to get the next step to move, I need to do the same thing of just exploding those and flattening them. I don't have to go through a lot of other steps. So utility, explode, geometry, and then flatten this. So what I want to do now is actually create a lofted surface between it. So basically these new higher curves gets lofted to those original curves that have been scaled, or at least their original location, just smaller. So go to Surface, Freeform, Ruled Surface. So again, I'm using these as my A input, then these ones become my B input. Now you can start to see how it creates this nice surface. And again, I've got these hollowed out areas that don't have any surface, that are the scaled parts. All I have to do for that is go to Freeform and Fragmented Patch. And now I've got that area filled in. We can start to see just how those different kind of extrusions are happening. And let's go ahead, turn this off. Now again, I'm going to bake this so we can see it a little bit better and turn it off. So now you can start to see how this type of extrusion works. It's obviously different from the others. I like it. It's got a nice kind of just subtle change where the diamonds themselves are kind of controlling it instead of the surface that's being created by them. So it's a pretty interesting new textured landscape. And again, I like it that the areas that are flat almost seem just perfectly flush, and then as soon as they start to get steeper, that subtlety starts to come out of the surface. All right, so it's a pretty interesting surface that's being generated from these. So that's it for this extrusion. The next series of videos will then look at how to create more linear extrusions instead of working with cells, but actually with more of the wireframe. So it's going to be a little bit different, but still have some interesting results.